Article 2514 of the National Electrical Code, also known as NEC, pertains to separately derived systems. These systems are alternating current systems without exterior connections to the utility grid. Separately derived systems, or SDSs, have their own dedicated source of electricity. Examples of this are generators or transformers. The original name for Article 2514 was Alternating Current Systems Without Exterior Connections. The article was renumbered in 1956. The concept of separately derived systems was initially developed for farmhouses that used generator power. In these early systems, grounding was not required for systems operating at 32 volts or below. The purpose of Article 2514 is to ensure electrical safety in separately derived systems. It does this by specifying requirements for grounding and fault protection. By connecting the system to a grounding electrode, the risk of electrical shock is reduced in the event of a fault. Traditionally, transformers have been considered separately derived systems. However, modern transformers are often connected to Earth at multiple locations. Because of this, they no longer fit the original definition of a separately derived system. When the neutral point, or XO, of a transformer is connected to Earth in two locations, it creates a ground loop. This can lead to common mode current and electromagnetic interference, or ME. This configuration is considered a violation of NEC requirements. In conclusion, transformers are not true separately derived systems. They should not be treated as such. Transformers only require an equipment ground conductor for fault clearing. Separately derived systems, on the other hand, require proper grounding to ensure electrical safety. It's important to understand the distinctions between these systems to comply with the National Electrical Code and maintain safe electrical installations. The NEC provides detailed guidelines for grounding and bonding. These guidelines are essential for preventing electrical hazards. Grounding ensures a low impedance path for fault current. This helps to quickly trip over current protection devices such as circuit breakers or fuses. Bonding connects non-current carrying metal parts to create an electrically conductive path. This minimizes voltage differences and reduces the risk of electric shock. Article 250 of the NEC covers grounding and bonding requirements in detail. It provides specific rules for different types of systems and equipment. Understanding Article 250 is crucial for electrical safety. Separately derived systems require a grounding electrode system. This system typically consists of a grounding electrode conductor connected to a grounding electrode. Common grounding electrodes include metal water pipes, ground rods, and concrete encased electrodes. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table specifies the conductor size based on the size of the service entrance conductors. Proper grounding ensures that fault current can safely return to the source. This protects people and equipment from electrical shock and damage. In contrast, transformers connected to the electrical grid do not require a separate grounding electrode system at the secondary. Instead, they rely on the equipment grounding conductor to provide a fault current path. The equipment grounding conductor connects the transformer enclosure and other non-current carrying metal parts to the electrical system ground. This ensures that any fault current will quickly trip the overcurrent protection device. Ground loops can create significant problems in electrical systems. They occur when there are multiple ground connections creating parallel paths for current flow. This can result in unwanted current circulating through the grounding system. Ground loop current can cause electromagnetic interference, voltage drops, and even equipment damage. To avoid ground loops, it's important to follow proper grounding and bonding practices. Single-point grounding is a common technique used to minimize ground loops. This involves connecting all ground conductors to a single point. This prevents current from circulating through multiple ground paths. Another important consideration is the use of isolated ground receptacles. These receptacles have a separate grounding conductor that is isolated from the normal equipment grounding conductor. This helps to reduce noise and interference in sensitive electronic equipment. When working with electrical systems, it's crucial to follow all applicable codes and standards. The NEC provides comprehensive guidelines for safe electrical installations. It's important to stay up to date with the latest edition of the NEC. This ensures that you are following the most current and relevant safety practices. In addition to the NEC, there may be local codes and regulations that apply. It's important to check with your local electrical inspector to ensure compliance. Proper training and education are essential for working safely with electricity. Electrical work should only be performed by qualified individuals. This includes licensed electricians and other trained professionals. Never attempt electrical work if you are not properly trained and qualified. Always use appropriate personal protective equipment, or PPE, when working with electricity. This includes safety glasses, gloves, and insulated tools. PPE helps to protect you from electrical shock and other hazards. Before starting any electrical work, always to energize the circuit. This can be done by turning off the circuit breaker or removing the fuse. Use a voltage tester to verify that the circuit is energized. Never assume that a circuit is energized without testing it first. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. These procedures involve placing a lock and tag on the circuit breaker or disconnect switch. This indicates that the circuit is being worked on and should not be energized. When working with separately derived systems, it's important to understand the specific requirements for grounding and bonding. These systems require a grounding electrode system that is separate from the utility grid. This ensures that fault current can safely return to the source. The grounding electrode system should be installed in accordance with NEC requirements. This includes using the correct size grounding electrode conductor and proper installation techniques. When installing a separately derived system, it's important to consider the potential for ground loops. Avoid creating multiple ground paths that can cause unwanted current flow. Single-point grounding and isolated ground receptacles can help to minimize ground loops. Transformers are commonly used in electrical systems to step up or step down voltage. They are not considered separately derived systems when connected to the electrical grid. Transformers require an equipment grounding conductor to provide a fault current path. The equipment grounding conductor should be properly sized and installed in accordance with NEC requirements. When installing transformers, it's important to consider the potential for harmonic currents. Harmonic currents can cause overheating and other problems in electrical systems. Harmonic filters can be used to reduce harmonic currents. Surge protection devices, or SPDs, can be used to protect electrical equipment from voltage surges. SPD should be installed at the service entrance and at sensitive equipment. They divert surge current to ground, protecting equipment from damage. Regular maintenance and inspection of electrical systems are essential for safety. This includes checking for loose connections, damaged wiring, and other potential hazards. Any problems should be corrected promptly to prevent electrical accidents. Electrical safety is everyone's responsibility. By following proper procedures and using safe work practices, we can prevent electrical accidents and protect ourselves and others from harm. Always be aware of the potential hazards of electricity and take steps to mitigate those risks. Continuous learning and professional development are important for staying up to date with the latest electrical safety practices. Attend training courses, read industry publications, and participate in professional organizations. This will help you to stay informed and improve your skills. Remember, electricity is a powerful force that must be treated with respect. By following proper safety procedures, we can harness its power safely and efficiently. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. They have the knowledge and experience to ensure that the work is done safely and correctly. The National Electrical Code is a living document that is updated regularly. It's important to stay informed of any changes to the code and to implement those changes in your work. The NEC is a valuable resource for electrical safety information. It provides comprehensive guidelines for all aspects of electrical installations. By following the NEC, we can ensure that our electrical systems are safe and reliable. Electrical safety is an ongoing process. It requires constant vigilance and a commitment to following best practices. By working together, we can create a safer environment for everyone. This discussion highlights key aspects of Article 2514 and related electrical safety practices. Always prioritize safety when working with electricity.